What is a phase change? Okay? A phase change is a change of state from one state of matter to another. Changing state from one state of matter to the other. Okay? Either changing from a solid to a liquid, liquid to a gas, gas to a liquid, liquid to a solid, gas to plasma, plasma to gas. Changing the state of the matter. Now, a phase change is a physical change because I'm still not actually changing the substance, right? It only affects the physical appearance, not the chemical makeup. Let's take the example of water, okay? If I want to take liquid water and turn it into a solid, what do we call solid water? Parker? Ice. If I want to change water, liquid water, into ice, do I still have water after changing it into ice? Yes. On a molecular level, I still have molecules of H2O. I've just changed the state from a liquid to a solid. I've taken them from moving around a little bit and being able to flow freely to now being stuck together and put in one place. But I haven't added anything else to it, nor have I taken anything away, correct? Okay, that means it's a physical change. Another hint to that, another hint that it is a physical change, not a chemical change, is it's reversible. If I change it from liquid water to ice, I can get it back to liquid water, right? It doesn't magically turn into orange juice. Okay, it's still the exact same substance, just changing its state. In order to change state or to change phases, you have to add or take away energy. If I want to get liquid water into water vapor, what would I do? How could I do that? How can I take my pot of water and turn it into steam? I had a pot of water, and I wanted to turn it into water steam, a steaming hot tub or whatever. How would I do that? Hattie?
Well, you would heat it up.
Very good. You would add heat. Okay? That would change it from a liquid state to a gas state. What if I had a block of ice that I want to change into liquid water? What would I do? Connor?
You would melt it.
You would melt it, adding heat. Okay? Now, heat is a form of energy. So, to get a substance from a solid to a liquid to a gas to a plasma, you have to add energy, usually in the form of heat. Okay? When you add energy, what do these atoms begin to do? Go ahead, Trinity. Hannah? Vibrate. Okay? When you add energy to the atoms, they begin to move. Then you add more energy, they move even faster. Then you add more energy, they move even faster. Okay? Now, interestingly enough, you cannot, okay, let's, about this. How about if I want to go from a liquid to a solid? What do I have to do? Liquid water, I want to change it into ice. What do I have to do? All hands should be up. Let's go. Come on. I want to change liquid water into ice. Kayla. Kayla.
You would add heat.
You would add heat to get liquid.
No, you would put it in a you would freeze it.
You would freeze it. Question. Can you add cold?
Yes.
Raise your hand if you think yes, you can add cold. Raise your hand if you think no, you cannot add cold. No.
That's not
okay,
not an answer.
Hands down. Technically, you cannot add cold. But you can take away heat. Okay? So, to get something from a gas to a liquid, I can't add cold. Cold is not a thing I can add. But I can take away energy, causing them to move slower and slower, and now turn into a liquid. If I take away more energy, take away more movement, now I can change it from a liquid to a solid. You see what I'm doing? Okay. So, for example, heating water on a stove is adding thermal energy, which is called heat, to the water, which, if I do that, will cause it to change from a blank to a blank. Connor, what do you think? Fill in the blank.
You add heat to water, it'll make gas.
Change it from a blank to a blank.
It'll change it from a liquid to a solid.
By adding
Liquid
heat,
to a gas.
liquid to a gas. Okay, putting a pot of water on the stove will change it from a liquid to a gas. This one. By taking away energy from the water in the bottle, the atoms slow down their movement and become still, forming ice. This is a change of state from a blank to a blank. Noah? Liquid to a solid. Very good. Okay? Those are phase changes. Landon? Add or take away energy. Caleb? Cool it off. If you have a plasma and you cool it, it would first turn back into a gas. If you can cool it even more, it turns to a liquid. Cool even more, turn into a solid. Now, depending on what atoms or what elements are in that plasma substance, the freezing point or the condensation point to get it from plasma back to a gas could be very, 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 very low. Every single substance has a different melting point, boiling point, changing point, or freezing point, condensation point, things like that. Typically, plasma, so for example, water is not something that you normally would have in a plasma state. Does that make sense? Usually it's much, much hotter gases. Ethan, A?
Can you change the solid into a gas?
Good question. There actually are a few substances that go straight from solid to a gas. You ever heard of dry ice?
Yeah.
Okay.
Yeah.
That substance goes straight from a solid to a gas. It skips the liquid phase altogether. Now, those are rare. Most of them go in this order. Okay. And I can't remember the name of them, but there's a particular name for substances that skip over the liquid phase. They go straight from a solid to evaporated to a gas. Good question. Okay. All right. At the bottom of your notes, I want you to draw these 3 diagrams. Okay? First box, you're going to draw atoms that are very close together. Okay? Underneath that, I want you to write the word gas.
Gas.
Sorry,
Solid.
Thank you. Solid. Okay? This diagram represents a solid material because all of the atoms are kind of stuck in their spot. There's no movement. No matter what you do, it will stay the same size and shape unless you add some form of energy to it. You don't have to make it this big either. We'll run out of time if you do. The next box, you're going to draw more atoms, but this time a little bit further apart. Okay? This diagram represents our liquid structure. Still made of atoms, still made of things, but those atoms are a little further apart. There's a little more movement in there. Then the last box, you're going to draw a box as well with atoms, but these atoms are much, much further apart. And then we're going to label that picture the gas. Again, to get it from solid to liquid to gas, you need to add energy and get those atoms moving even more. Connor?
So what would liquid nitrogen be? Would it be with water, or would it be kind of like a gas? Because
Liquid nitrogen?
Yeah.
It would be a liquid. What do you mean?
Could liquid nitrogen become a solid?
If you freeze it enough, yeah.
But it's already really, really cold. So way
Correct.
below freezing. But how would you freeze to become a solid? It's already frozen way below zero.
Not frozen. That just means that the point at which it goes from a gas to a liquid is a super, super low temperature. Even further low, you could get it from a liquid to a solid. Reagan?
I kind of highly doubt this, but can you literally change any solid to a liquid because it would make sense because you can increase the energy between the molecules, changing their molecular structure. But that depends on what object it is, easier or not. Because I feel like paper, it would take a while, or it just wouldn't change.
Yes. So paper is one of those substances where when you heat it up, it doesn't instead of like melting, it burns. So because of that property, it doesn't really go back into a liquid phase, nor a gas.
Also, when you have like in concrete, you see like you pour water on it, the water it either spreads and it kind of like soaks into the little cracks. It's not necessarily like evaporating, but would it be like going into the concrete and kind of going into basically solid state?
Not necessarily a solid. It either spreads out so thin that it evaporates, or it either spreads out like through all the pores and then sinks below, like beneath it, or it gets absorbed into the concrete. Yeah. Yes.
So isn't like dry ice like where it turns from a solid to a gas? Isn't that just frozen nitrogen?
Yes. Yes. I can't remember if it's nitrogen or something, but I believe it. That sounds right. Yeah. Wait, dry ice?
Yes.
No, I think dry. If I remember correctly, I think dry ice is carbon dioxide.
Yeah.
If I remember correctly. Yes.
So first of all, is it possible for every single material to turn into plasma?
As far as I know. I really haven't done much. There hasn't been a whole lot of study on plasma because we just don't really interact with it on the surface of the Earth very much.
And then second, how is it possible for atoms that is split up in plasma to come back together and turn into a gas?
I don't know. Good question. All right, so what are physical properties from the second set of notes? Just as a review, you're going to rewrite this definition. You can stop at the parentheses though. Okay? Physical properties. As a review, this is anything that you can observe or describe about an object. Anything you can observe or describe about an object. Okay? Now, we've already discussed one example of a physical property. The state of the matter. Is it a solid? Is it a liquid? Is it a gas? Is it a plasma? We're going to move on to another physical property. Nicholas, put that away. This time we're going to talk about mass. Mass is the measure of the amount of matter an object contains. If matter is made of atoms, then measuring the mass is measuring how much atoms are in that object. Okay? To measure the mass, we use an object called a triple beam balance. Mass is measured using a triple beam balance. Okay? Let me get to my notes here real quick. Okay? Now, there are two types of balances. This is the triple beam balance. This is a little bit easier to use, a little more scientific. This one is just a regular, almost like a scale balance. Yes.
We're gonna watch the videos.
Okay. I'm going to show you how to use this balance, the regular balance first. Then I'll show you how to use triple beam balance. Okay? I'm going to try and do it on this chair so I can hopefully get it in the recording. Let me see. Yes.
Why did it say balance?
because you can use a balance or a triple beam balance. They're two different objects. Now, ideally, you want to use a triple beam balance. All right. I'm going to show you how to use this regular balance. Okay. People online or the video, it's going to be a little difficult, but hopefully you should get the gist of it. If you're towards the back and need to stand, that's fine. Just stay kind of at your depth, but you can stand if you need to. Okay. So the way it works is like this. You have your two containers on each side. Okay. And this one would be your pan. There's two pans on each side. Okay. And it should, if everything is equal, it should start with this little pointer guy. There's a little point at the bottom of this middle balance here. Should be directly in the middle. Okay? If it's not directly in the middle and it's off like this, you could tell that this side is too heavy. And it's starting off on not balanced. Does that make sense? Okay. So you want to make sure your balance is starting with it right in the middle. Okay? Then you place the let's say we want to measure the mass of the highlighter. Okay? You place the object on one side of the balance. Notice it should tip down. Okay? That means there's more mass on this side than there is on this side. But I want to know how much mass is in here. So I'm going to keep adding mass to this side until I balance the thing back out. Okay? So these balances come with what we call mass pieces. Let me get them out so I can show you. Where's my little tin bag? Oh, there you go. Okay. You see how I have these little blocks, these little pieces? Mm-hmm. Okay. This is a 20-gram piece. This is a 10-gram piece. This is a 5-gram piece. This is a 1-gram piece. Little itty-bitty token sort of thing. Okay. You want to start by dropping gram pieces into the other side. I'm going to start with my 20. Why is this one now on the more tilted down more than this side? Sophie? Good. So now I know this is too much. Okay? So now I'm going to try my 10-gram piece. Is that enough?
No.
No. But is it too much?
No.
No. So I'm going to leave the 10-gram piece in there and keep adding other sizes. Now I'm going to add a 5-gram piece. Is it in the middle?
No.
Parker, what do you think? You're closest. Is it in the middle or is it off?
Exactly, but
Okay, so it's not exactly. So I'm going to see if I can make it a little better. I'm going to take my 5-piece back out. And now I'm going to add 1-gram pieces and see if I like that better. Because if 5 is too much, my other unit is 1. Okay? Is that enough, Parker?
no. We can both do it as well. It might end up being more than 5. No, it's still like.
Well, let me put it in the middle. I'm trying to see. Too much? Okay.
Probably because it's in the middle. It depends on where you put it.
How's that?
Well,
A little off?
Yeah, just a little off.
Let me stack these up and see if that makes a difference.
That's better.
still a little off.
How's that?
There. That's good.
Pretty good? Okay. Let's add one more and see if it's too much.
Nope.
No? So that was 5 grams. So let's add my 5-gram piece back.
Yeah.
Oh, then yeah.
Good?
Yep.
Okay. So once you have it equal, and it's never going to be perfect, okay? But you have it as equal as you can get it to where this is pointing in the middle as much as possible. Then you take out the total pieces you put in and add them up. I have a 10 and a 5. So how many total grams do I have? Class?
15.
15 grams. That means the mass of my highlighter is 15 grams. Does that make sense? Okay. So that's how you measure mass using a balance like this. Now I'm going to show you how to measure the mass using the triple beam balance. Okay? I'm going to start by showing you the video, and then I'll show you how to do it